Welcome to today's Explainer, where we're going to explore how dynamic, on-demand energy networks are completely changing the landscape of electric vehicle charging. Seriously, we're looking at a massive paradigm shift here, moving from rigid, stationary infrastructure to fluid power delivery, and honestly, it is absolutely fascinating.
All right, picture this scenario. You're stranded on the shoulder of the highway. Your battery is sitting at 0%. It's literally every EV driver's worst nightmare, right? So what do? Do you call a traditional tow truck, or do you order a mobile EV charger? The choice you make right there impacts your wallet and ruins your afternoon. And as we'll see, the answer to this is rapidly changing the entire roadside assistance industry.
So here's our roadmap for this Explainer. First, the EV charging bottleneck. Then, towing versus mobile charging, followed by charging as a service. After that, we'll dive into the OCCP data revolution, do a Caltrans reality check, and finally, look at putting power where you need it. We're going to connect the dots from everyday roadside emergencies all the way up to macro-level grid logistics. Okay, jumping into Section 1, the EV charging bottleneck, and why the grid is holding back fleets.
So let's start with the massive logistical nightmare that commercial fleet managers are facing today. The core problem? It's all about time. Imagine taking delivery of a brand new EV fleet today. If you go the traditional route of fixed infrastructure, you might be waiting a staggering 18 months for a utility grid upgrade. 18 months! Not to mention dealing with costly trenching and endless permitting. But off-grid mobile deployment companies like SparkCharge, they can get a fleet charging in just 7 days. It's night and day. They effectively bypass the grid entirely. Moving on to Section 2, towing versus mobile charging, looking at the decision matrix for stranded drivers.
So how does this bottleneck affect you, the individual consumer, when you're suddenly stranded on the side of the road? Well, the golden rule here is distinguishing between a power problem and a mechanical one. If your battery is dead but the car is otherwise totally fine, call a mobile charger. But if you have suspension issues or, say, saltwater damage, which, by the way, is instant kryptonite to high-voltage systems, you strictly need a flatbed tow truck. No exceptions. And what's really interesting is how local geography actually throws a massive wrench into this whole decision tree. Take South Florida, for example. The extreme heat down there, routinely baking at over 90 degrees Fahrenheit, that significantly accelerates battery degradation if a depleted EV is just left sitting out in the sun. Add in the looming threat of storm surge flooding, and again, you absolutely cannot charge a flooded vehicle, and you have to make a very rapid triage decision. Do you dispatch a mobile charger to deliver usable range in 30 minutes, or do you just send a flatbed tow? All right, Section 3, charging as a service, or CAUS, off-grid power generation and storage. To completely bypass these bottlenecks for both consumers and fleets, companies are pioneering an entirely new operational model. By bundling the hardware into a charging as a service model, they're basically removing all the friction of adoption. SparkCharge, for instance, allows fleets to deploy their power hub generation and modular battery energy storage with zero upfront capital expenditures. $0. That's a huge, unexpected benefit for operators who are used to million-dollar construction bills. SparkCharge handles all the operations and maintenance, they guarantee 99.9% uptime, and the fleet manager, they simply pay for the energy they use. It's much like a utility bill, just without that crazy 18-month wait. And the sheer power being delivered here? It's incredible. To handle heavy commercial demand, companies like Door Energy have developed rapid dispatch systems that can push out a massive 420 kilowatts of DC fast charging output. Plus, and this is crucial, these systems are fully compatible with major North American and European charging standards, like those standard CCS1 and CCS2 plugs you're used to seeing at most public stations. Which brings us to Section 4, the OCCP data revolution, making mobile chargers intelligent. You see, hardware is really only half the story. You can't just send massive batteries out into the world blindly, right? This is where the Open Charge Point Protocol, or OCCP, steps in. Think of OCCP as the brain. It transforms a mobile charger from a simple, disconnected power bank into a highly intelligent node on a network. It allows the unit to constantly broadcast its live location, its battery status, power output, and even fault data back to a central management platform. Because of this, we're effectively moving from a reactive, guess where the tow truck is model to highly efficient digital rescue. Instead of manual phone dispatches, OCPB enables automated, completely data-driven power delivery. Operators know exactly which mobile unit has the highest charge, they know exactly where it's located, and they can dispatch it instantly to restore energy right on site. It's a game changer.
All right, let's look at Section 5, Caltrans Reality Check, Pragmatic Deployment and Limitations. So let's look at the pragmatic reality of actually deploying these systems on the ground. Because as amazing as this tech sounds on paper, it's definitely not without its growing pains. Thanks to rigorous testing data on the Caltrans fleet, which was evaluated by the Advanced Highway Maintenance and Construction Technology Center, we know exactly what happens when this tech hits the real world.
Look at this data. The contrast in requirements here is literally staggering. The EVSCO unit is truly mobile, but it demands a trailer, a solid internet connection, and heavy 480-volt AC power just to recharge itself. Meanwhile, FreeWire's boost charger system, which, by the way, is marketed as flexible, actually required a permanent concrete foundation and got completely tangled up in fire marshal permitting delays.
So the reality check here? This tech is far from flawless right now. Testers saw the EVSCO unit hit only a 35% success rate with DC fast charging compatibility, and charge point stations ended up being the most reliable way to recharge it. They also saw intermittent charging failures with Tesla vehicles and battery cell errors popping up in cold weather. And that FreeWire unit? Its programming kept the internal battery state of charge, or SOC, so incredibly high at 98.5% that it practically cooked its own battery into early degradation. Finally, Section 6, Power Where You Need It, the multi-scenario future of EV charging. Despite these growing pains, the applications for this are expanding rapidly, way beyond just roadside assistance and fleet depots. Think beyond cars for a second. We're talking about remote construction sites running electric excavators miles off the grid, or data centers, which currently face agonizing 5-year waits for grid connections, using mobile batteries to come online instantly. We're seeing it in busy logistics ports to keep cargo moving seamlessly, and it's even becoming the backbone for autonomous vehicles that need to roam and charge 24/7. The shift taking place is incredibly clear. We are moving away from a rigid, stationary infrastructure mindset and moving toward a fluid, data-driven web of mobile energy that dynamically responds to exactly where power is needed most. As the quote goes, the future of EV charging isn't just about permanent stations, but dynamic, on-demand energy networks. So I want to leave you with this final thought today. As mobile charging as a service scales up and these massive intelligent batteries can be dispatched directly to our exact locations, it kind of forces us to completely rethink how we plan the cities and infrastructure of tomorrow. I mean, if the charger can just come to you, do we really need a permanent plug-in in every single parking spot? Thank you for joining me on today's Explainer. I hope this sparks some new ideas for you, and I'll catch you in the next one.